Chapter 8, Combined Loading, Application of Superposition in Thin Walled Section. Example number 1. In this example, we have a gas tank with inner radius of 24 inches. Let's have it a inner radius of 24 inches and a thickness of 0.5 inches. That's the thickness of my a thin walled shaft and also gas tank, and also which happen to handle a concentrated load of 1500 at its top, and the pressure inside is 2 psi, pound per square inches. We want to know what is the stress or state of stress at point A. What are our stresses at point A? Let's approach this problem. So first we need to check if this section is a thin walled or not, to see how we can apply the hoop stress and circumferential and so longitudinal stresses. So radius over thickness is 24, which is a radius, and the total of that is our diameter is 48 inches. So our radius is provided to be 24. It turns out a diameter of 48 inches. So 24 over 0.5 is 48 and is far bigger than a numeric value, and we do know for thin wall section, if our radius to thickness is bigger than value of 10, our wall is our vessel considered like a thin wall vessel. So definitely 48 is far bigger than 10, so it's definitely a thin wall section. And also the very first part is the reason so we do the checking for a thin wall section, because all thin wall section are a kind of hollow section, but all the hollow section are not thin wall section. So we do need the requirement of r radius over t bigger, at least a radius should be 10 times bigger than the thickness, that we can consider it like a thin wall section. Else it's just a simple hollow section. So as soon as we have our first checking, let's go for the circumferential stress at point A, and the equation for that is just a sigma 1 circumferential or hoop stress. If you remember from previous part, that's a internal pressure times radius over the thickness of your plate. If you replace the numeric value from problem statement, 2 psi times 24 inches over 0.5 inch, it just gives us 96 pound square inch for our a hoop or circumferential stresses at point A. So that's sigma A at point A. And also let's see how about the longitudinal one. So longitudinal stress, if we cut the section at the point A, we will experience a something like a balanced section. 1500 applies at the top. It should be cancelled out by the effect of the again, because the section is at balance section condition. So if you want to see the effect of sigma 2, that's a to this external force, we do have a normal stress, which is a compression negative normal force over the area. So that's 1500 the area plus PR this time over 2 times thickness. So the first one is a 1500 pounds, which applies at this narrow strip of area. Then we can simply say if the thickness is 5, the inner diameter is 24. Means if you just add up thickness to this value, it just gives you 24.5 in terms of external part, and the pi r square is the area minus the internal one. It just gives us the surrounding area inch squared, then plus a 2 psi, which is the internal pressure of the gas, times 24, which is the diameter radius, over 2 this time. Because of the formula, it just gives us two of them, and it just gives us a numeric value of sigma 2, a 28 point pound square inches. And then for combined loading, if you add up these two stresses, it just gives you the summation of longitudinal and circumferential, and that's the total. So it just says if you take out a cubic element out of this part and the structure, and you want to see the effect of longitudinal and circumferential stresses, these are my longitudinal. Let's have it here. Longitudinal stress, these two, and we can also have a circumferential or stress at both sides. So again, as you can see, the longitudinal one applies at the direction of structure or loading. If it's a vertical loading, your longitudinal is something like a norm, like what you can see here. Something like this load is in a vertical condition. Longitudinal one, it just goes along the structure, and the hoop stress or circumferential are the something like a 90 degrees. They just had a 90 degrees with the longitudinal one. So that's a first example, or something like second. It just will solve more example combined loading. So thank you. See you next videos.